Hey, what's up? It's Powell, and in this video I'm going to continue my discussion on polynomial long division. I did a video earlier about a couple of examples of polynomial long division, but I want to do a couple more because, as I mentioned at the end of that video, some weird stuff happens in some of these examples. So the first example I'm going to do is 2x to the fourth plus 7 divided by x squared minus 1. Now, as I mentioned in the last video, if you look at 2x to the fourth plus 7, you'll notice that the cubic term, the quadratic term, and the linear term are all missing. So we do have to account for those in the dividend. So I have 2x to the fourth, and since there's no cubic term, I'm going to write that as 0x cubed. And since there's no quadratic term, I'm going to write that as 0x squared. And since there's no linear term, I have to write that as 0x and then plus 7. So you always have to put in something to represent any terms that are missing. It's always 0x to the whatever is missing. But you might notice that in my divisor, x squared minus 1, there's a term also missing. There's no linear term. There's no x. I also have to do that for divisors. So my divisor is x squared plus 0x minus 1. So not only do you have to do that for the dividend, but you also have to do that for divisors. Now, just like the last examples, I have to look at the first term of each and figure out what I need to multiply x squared by to cancel out 2x to the fourth, or to equal 2x to the fourth, because I'm going to subtract them out. And that's, of course, 2x squared. This is bugging me. Hold on. That's better. Okay. And I'm going to distribute 2x squared over my divisor. So 2x squared times x squared is 2x to the fourth. 2x squared times 0x is plus 0x cubed. It's really 0, but 0x cubed. And then 2x squared times negative 1 is negative 2x squared. And I subtract. So 2x to the fourth minus itself is 0. 0x cubed minus 0x cubed is nothing. And 0x cubed minus negative 2x squared is positive 2x squared because we're subtracting a negative. Now, of course, it's weird for me to put 0x cubed. It would be 0, but I want to make sure that I know what was supposed to be there so I can line them up. So taking a little creative license with this. Now, since all the terms except for the last canceled out, I only have one left. So if I drop down the 0x, I have two terms under the fraction bar, or under the division bar, but I have three terms in my divisor. So I have to skip a step and bring down the 7 as well. And what do I multiply x squared by to get rid of 2x squared? I multiply it by 2, which I'm going to write over the 7 because their degree are the same. So notice I didn't multiply by any linear terms, and that's okay because I had to drop down an extra term, so I skipped that one. And then I just distribute the 2 over my divisor, so I get 2x squared. 2 times 0x is 0x, and 2 times negative 1 is minus 2. And then 7 minus a negative 2 is 7 plus 2, or 9, which is my remainder. So my quotient is 2x squared plus 2, and then plus 9 over my divisor, which was x squared minus 1. And that's my solution. So again, with the remainder theorem, you put the remainder, if there is one, you put the remainder over the divisor and you add it onto the end of your quotient. So that's my quotient. So let's skip over to this example where I have 5x to the fourth plus 14x cubed plus 9x divided by x squared plus 3x. So you'll notice there are terms missing in both the dividend and the divisor. So I have 5x to the fourth plus 14x cubed plus 0x squared, because there's no x squared, plus 9x. But don't forget that there's no constant on the end, so I need a plus 0 on the end. So even though because there's no constant, I need a 0 to represent the constant. There's my division bar, And as with the last example, I do have a term missing in the divisor, and that is the constant, so a 0 goes on the end of that as well. So I have to look at x squared, 5x to the fourth, and I have to multiply x squared by 5x squared to make it equal to 5x to the fourth. So 5x squared, distribute that over our divisor, we get 5x to the fourth plus 15x cubed plus 0x squared. The 5x to the fourths subtract away. 14x cubed minus 15x cubed is negative x cubed. I guess I'll keep that blue, but I'm going to make the rest of this black. Okay. And the 0x squared also becomes 0x squared. And again, it should be 0, but I'm going to keep the x squared there as a placeholder. And I drop down the 9x. I do the whole process over. So what do I multiply x squared by to get negative x cubed? Well, that, of course, is negative x. Distribute that over the divisor. I get negative x cubed minus 3x squared minus 0x. Again, I'll write this. Sorry, I keep changing colors. And now I'm going to subtract these. So the x cubes, the negative x cubes subtract off. 0x squared minus negative 3x squared is positive 3x squared. And then 9x minus 0x squared is 9x. And then I bring down that plus 0 in the end. And then lastly, I need to multiply something by x squared to cancel out 3x squared, and that of course is 3. So distributing the 3 over the divisor, I get 3x squared. 3 times 3x is 9x. 3 times 0 is 0. And when you look at that, those all subtract away, so I get a remainder of 0. So my quotient is 5x squared minus x plus 3 with no remainder. So I don't have to tack anything on the end. So those are two other examples where you have to fill in missing terms when you're doing polynomial long division. And it's also a good example of what you do with higher order divisors like x squareds. If you like this video, please subscribe and comment below on any topic you'd like me to cover in the future. And thank you very much for watching.